I would like to start with the overview. So here we see the different parts of the presentation, 4 in total. Part number 1, conventional system. Part number 2, bus system. Part number 3, bus system advantages. And last but not least, part number 4, KNX-specific advantages. In general, our today's goal is to point out the most important advantage of KNX, which is its flexibility. I will just start with the conventional technology and then later on compare it after having converted it first into a KNX bus system, and then explain you the different aspects and also the advantages in comparison. So let's start. Conventional systems are based on 3 switch types, which we see them here. On the left side, we see the simple switch. In the middle, we see the toggle switch. And on the right side, the cross switch. So a simple switch has actually only 2 connections, which means that only 2 wires are actually connected to it. It has 2 positions that are called open and closed. For toggle switches, we see 3 connections, meaning 3 wires, and they obviously also have 2 positions. We rather call them here left or right. For the cross switch, there are 4 wires required in order to set it up, 4 connections. We call the positions here parallel and crossed. Let's make a conventional system, the most simple one, which is the single switch function. That means that there is only one operating point. The electrical consumer, we call it E1, is a lamp. The simple switch in between S1 is just to operate that lamp. In fact, the status of the lamp E1 depends directly on the status of the switch. If the switch S1 is open, then E1 is 0, which means that the light is switched off. Whereas if S1 is closed, then E1 is 1, which means that the lamp is switched on. Simple. And that is actually shown in the truth table that you can see on the upper right corner. Let's go one step further and have the same electrical consumer, E1, to be operated via 2 independent operating points. In order to set this up, we need to use the toggle switches, so no longer a single switch, because that will not work. The toggle switches, here we call them S1 and S2, and you can see them on the right side. Now, the truth table becomes a little bit more complicated than before, because we need to look at the combined positions of these 2 switches. Therefore, the conclusion of the truth table is as follows. The lamp will be switched on if S1 and S2 are in the same position. If both switches are either both left or both right, then the lamp will be switched on. In the other case, when S1 and S2 are in opposite positions, then the lamp will be switched off. In the next step, we will still use S1 and S3, this time as toggle switches, but in between of those 2 toggle switches, we will place the cross switch. We do that because we need to have 3 independent operating points and no longer 2. We keep the same electrical consumer E1, and consequently, this is the truth table. So it becomes a bit more complicated, as you can see. The conclusion of the truth table is as follows. The lamp will be switched on in the following cases. The first one is when S1 and S3, so the 2 toggle switches, are in the same position, and S2, the cross switch in between, is in a parallel position. The second case is where S1 and S3, so again the two toggle switches, are in opposite positions, and S2, the cross switch in between, is in the cross position. Just leave the slide here so that you can see a bit more the electrical circuit here. Still one level up is the multiple switch function, which means at least 3 operating points. To set it up, we always use two toggle switches, A1 and A2, and in between we put a series of cross switches, the number of which depends on the number of independent operating points that we would like to have for the electrical consumer E1. The truth table of such a function will only become longer and longer. So the more cross switches that we add, the more independent operating points we want, the larger the table gets. The conclusion of such a table is always the same. If we want to have the lamp switch on, there are two cases. Case 1 is where A1 and A2, the two toggle switches, are in the same position. Then, in between of those two toggle switches, there needs to be an even number of cross switches in the cross position. Case 2 is where A1 and A2 are in the opposite positions. Then, in between of those two toggle switches, there needs to be an odd number of cross switches in the cross position. You see that just trying to put this under words already indicates actually how complicated this can get, and is just a simple binary on-off function with just a multiple number of independent operating points, which as such is not really that complicated. However, in the conventional world, it is complicated. So what I've just said. So what is the conclusion? The conclusion is that with a conventional system where the functionality is hardwired, hardwired comes with some disadvantages. It means the cabling is complex. Complex means time consuming. Time means money. So this is indeed is expensive just for cabling, which is the most important disadvantage. Then what we see here is actually a step towards the alternatives, a step towards a bus system. Therefore, what we will do is instead of using a hardwiring system, we will use ICT in a bus system. ICT is the alternative, which is the abbreviation for information and communication technology. So what we will actually do is to just replace all the switches that we have in a conventional system by microcontrollers and link these microcontrollers via a bus. And that's what we see here. I took as an example the triple switch function, so the 3 independent operating points for the electrical consumer E1. So you might recognize it. Instead of putting it in a vertical position, we put it now in a horizontal position. So let's convert the system. We will do that step by step. So just by replacing every switch, example given S1 by microcontroller, S2, the cross switch, also by microcontroller, S3, the same, and also the electrical consumer, we will replace by a microcontroller in combination with a relay, because E1 is supposed to be either switched on or off. Therefore, a relay will perfectly fit here. As I said before, all these microcontrollers will be linked together via a bus cable. All the microcontrollers except one are on the left side, which is on the right side and is the one that operates the relay. You see here. And which consequently influences the status of E1. All the microcontrollers on the left side operate on E1.
Does this mean that conventional electrical installations shall not be realized anymore?
That's a very good question, Jesus. The conventional electrical installations evolve as the needs and the requirements for the buildings evolve. That means that if a building requires, example given, remote management via internet and individual room control, then realizing that in a conventional way might be extremely expensive or even impossible. Therefore, the evolution of the electrical installations are the bus-based electrical installations. So let's have a look now on the bus systems and see how they operate. So far, we have learned how to convert a conventional system into a bus system. Now, let's have a look at the different aspects of such a bus system in order to understand it better and point out its advantages. The first aspect is the divided functionality. We see a number of microcontrollers that serve a specific role in this context. Let's call the group of these microcontrollers that I have put here in this rectangle sensors. Sensors are actually bus devices that send information to the bus. Why that? Because when one manipulates a push button, a rocker somewhere in an installation, it means that, example given, someone wants to switch on a lamp somewhere. It can also be a physical sensor, a device that sends regularly, example given, temperature information about a room somewhere. Then we can see the other end here on the right side. And in this case is just one actuator, which is actually the bus device that connects electrical consumers to the bus. And that's what we see here. A lamp that is of course connected to the mains. However, it is also connected to the bus via this relay, which is controlled via the bus. Therefore, we call this device an actuator. The next aspect of the bus systems is the message exchange. So how do we switch on this lamp now? What is the technology used here, or what is the concept? When someone manipulates here this rocker from this push button, then it means that this microcontroller will send out a message to the bus. It's a kind of electronic message, of course, that will propagate through the entire bus. Such message has two parameters, of which the first parameter is actually the identifier of the electrical consumer, so in this case the lamp E1. The second parameter indicates what we want to do with the electrical consumer. In our case here, indicates 1 or 0 if we want to switch it on or off. So the message will then eventually be received by the actuator. So it's sent out by the sensor, received by the actuator, and the actuator will then react to it accordingly, either switches on or switches off the lamp via the relay. So to make a comparison, looking back at conventional systems, we can say that for a conventional system, the operating elements and the electrical consumers are directly and physically linked via wires. In a bus system, the operating elements are called sensors, and the electrical consumers connected via the actuators are indirectly or virtually linked via address parameters in messages. That they are exchanged between these sensors and actuators. So it's a totally different system, a totally different approach, a totally different concept, which comes with a lot of advantages.
Well, definitely looks much more simplified if you want to control an electrical installation.
Yes, and there will be even more. Let's look at the advantages right now. As such, the cabling of a bus system is really easy, because what you need to wire, in fact, are the microcontrollers together via a bus cable. Concretely, a bus cable is a low voltage cable. In case of KNX is 29 volts. Also, the only thing that needs to happen here is to respect a certain coloring code. So red goes to red and black goes to black. And that's how we can always add devices, extend the installation. Even for the actuators, it's not really that hard, because we just need to connect the output channel of such a microcontroller to the mains, and we do that for each actuator individually. Therefore, even that cabling aspect is really easy. Because of the easy cabling, we can say that at least that aspect is a time saver. It makes it cheaper, actually, so that the cabling aspect of a bus system as such is cheaper. What I would like to point out is that, of course, such a bus system is not used for just one function. So not just for E1. It can also be used for E2. It can be used for a lot of functions, of course, which makes it even cheaper. Another aspect of advantages that we see is that the actuators can combine lamps. So it's not one microcontroller per electrical consumer. It can be a 2-fold, 4-fold, 8-fold, etc. So that makes it a bit cheaper, and also from the consuming point of view, if one can save a microcontroller, then you can save energy consumption. A microcontroller maybe doesn't consume that much, but still it consumes energy. So we also see here an advantage. Next advantage is that not only we can see that functions can be combined within an actuator, or that we can have multiple channel devices, but we also see the same for sensors. Example given, a 2-fold, a 4-fold push button. Not only that, we can also combine function types within a sensor. This is what is shown here. Example given, E1, the left rocker, operates this electrical consumer E1, which is a lamp, and E4, the right rocker, operates on an electrical motor that maybe drives a garage gate or blind somewhere, and it's another function type. So also here we see yet another optimization of a bus system. In order to introduce yet another advantage, we have to present another aspect first. The bus systems also require interfaces, actually. So far, we have been talking about the runtime aspect of a bus system. So we have been talking about sensors and actuators, but there is also the need for interface, because a KNX bus installation needs also to be managed, and indeed, sometimes diagnostics might be also required, as things might, of course, go wrong, and consequently, we need to investigate. And for that, again, we need always an interface. So what is an interface? An interface is actually something that allows us to connect a software tool that runs on a computer with a bus, and then we have all functionality that we need for management and diagnostics. Here we see yet another advantage. In order to compare it again with a conventional system, we can say that a conventional system, if one wants to change something there, needs to rewire the installation. In contrast with the bus system, where instead of rewiring, one will just reprogram the sensors and the actuators that are involved there, which are in fact microcontrollers. The microcontrollers have a memory image that defines their functionality. So, in order to change the functionality, one just overrides the microcontroller's memory, and that is exactly the role of the software tool.
Sounds great, but how can you actually realize that? Because I see that there is a software required here to program those microcontrollers devices, isn't it?
Yes, indeed. There's a software required for that task, correct.
But then do you need to have any programming skills, learn programming language to be able to use this software?
Not at all. In fact, programming skills are not required. All you need is our software, ETS, and look how easy it is. The software actually makes our life really, really easy, since we can do really nice things in a very pleasant and efficient way. A few examples. Fine-tuning a function is one of the possibilities that we have with the software tool. Concretely, E1 has been set up as a lighting actuator and is a lamp that is switched on and off somewhere. And we would like to have the staircase features. That could happen if E1 is, example given, installed in a corridor in an apartment building. So the desired behavior now is that this lamp will be switched off automatically after a while. Example given after 1 minute. So instead of having the lamp to be switched on and off manually, or with a conventional timer that we will have to rewire, we just add the staircase feature with a few mouse clicks in the software, and that's it. It only takes a few mouse clicks, and a bit later we have that extra feature on board in the KNX installation. Modifying a function is also not an issue, which means that if we would like to have lamp E2 instead of E1 in the staircase function, then no problem again. With a few mouse clicks within the software, we have that modification. Adding a function to a device, also there the same principle applies. If we have devices with multiple channels, which is very common nowadays, we have a 4-fold dimming actuator. Then, if 2 of them are already used, there is no problem to add 2 additional ones. Also, this just takes few mouse clicks, and a bit later we have that extra functionality on board. I have talked about the software principles in a bus system in general. In KNX, this software is called ETS. ETS is the abbreviation for Engineering Tool Software and is the unique software for all KNX devices worldwide. In case you would like to find out more information about our software, then I would recommend you to have a look on our website at www.knx.org, and then you can find every information that you need. I would like to state that the KNX function I have been talking so far, the electrical consumer actually, is represented by an identifier, which we call group address, and identifies the electrical consumer. In this case, the KNX function E1 is represented by the group address 0/0/1. Please note the specific notation with the slashes. That's actually a notation for a group address in ETS. What we see here as an example is an ETS screenshot in which there is a collection of group addresses. I picked up one specifically, E1, the function that I have been using all the time, and we can see 2 devices, 1 sensor and 1 actuator. If we want to extend this function with more sensors, in other words, if we want more independent operating points, then because of the convenience of ETS, we only need to click around and use the keyboard to do that. Very easy. Here we see the result of such an operation. We see 10 more sensors for the same function E1. And again, it's really easy to do. This means that we have, in comparison with a conventional system, a flexible system. If you need to add 10 more independent operating points in this function with conventional technology, it will take you much more time than just here with ETS and few clicks. Now, the same function, E1, can also be extended in another way, and that is by adding 3 more actuators. And this is what we did here. Same principle here. It only takes a few mouse clicks and a bit with a keyboard, but actually all happens with the software. All happens within ETS.
So that means that adding more sensors and more actuators to a function can be done really quickly and easily?
Of course, of course. Of course, it's easy and fast compared to a conventional electrical installation, where you actually have to pull kilometers of cables if you want to realize such constellation.
And there are any concrete advantages if one uses the KNX?
Yes, of course. That's why we're here to present them. And thanks for giving me actually the step to point them out. So these are the KNX-specific advantages. First of all, KNX means saving energy. We can see that due to proof with facts, as there have been publications based on independent scientific research where universities have been working on this investigation. They have found out that indeed up to 40% of the total energy that is consumed within a building can be saved thanks to KNX shading control. Also, 50% of that same total energy can be saved by using KNX individual room control, 60% by using KNX lighting control, and also 60% by using KNX ventilation control. Of course, these are all individual control types. If you combine the several controls, then of course the percentage will only go up. Therefore, a lot of energy can be saved with KNX. Last but not least, KNX is actually a future-proof system because of its standardization. Because the KNX logo means something. It's not just a logo. It really means 4 things. First of all, the KNX logo means that this device is compatible with any other KNX device, regardless of the manufacturer. Consequently, the logo is really the guarantee for compatibility and for being a manufacturer-independent system. The KNX logo also means that the device can be configured with ETS, which, as we said before, is a unique standalone software which is compatible with any KNX device out there in the market. The KNX logo also means that the device has passed quality control tests, because one of the requirements in order to certify a device and getting the KNX logo is that the KNX manufacturer is ISO 9001 compliant. This means, of course, that the production plant where the device is manufactured needs to have a quality control system established. By having this quality control system, there is indeed a positive effect on the quality of the product. Last item here, but also very important, the KNX logo means that the device is backwards compatible. That means that the KNX installation can at any time be extended and maintained. It is a future-proof system. Therefore, to give you 2 examples to look in a different view on the same aspect. Example given. If we need to maintain an installation that was set up 25 or even 30 years ago, that is never an issue, because we know that if there is a defective product somewhere in that installation, we can always replace it by something that is on the market today. That is just a guarantee, we know that. Therefore, I say KNX is a safe investment. Or the other way around, if we set up a KNX installation today, then we know that within 20, 25, 30 years, if a device gets defective, then also no problem. We just replace it by anything that is on the market at that time, and it will work. And
well, wow,
yeah,
thank you very much. That's it. Yeah, for this presentation. I think it is pretty clear by now. And I want to say that I want to invite now our participants to drop their questions, which they already did. So I hope you are ready to answer.
yep, thank you.
Yeah, so we got some questions. For instance, is this interface open or it is only a proprietary system? Perhaps it's going to be answered later. So is the interface that you were mentioning when you were talking about how to program the installation, is that interface proprietary, or what can you say about it?
Actually, KNX system is an open system, so the specifications are open and available to everybody. KNX is not a closed, is not a proprietary system. Therefore, the interface that can be used to connect to KNX installation can either be a USB interface, so KNX to USB, or it can be IP to KNX, and the specifications of such an interface are open. Everybody can manufacture such an interface to connect to an installation.
Thank you. More questions? Are KNX components protected against electromagnetic pulses, which might wipe memory and therewith impair functionality?
To be honest, your connection was not really good. Could you please repeat the question, Jesus?
Yeah, are KNX components protected against electromagnetic pulses, which can affect their memory and then make them faulty within the installation?
Yes, of course. These are standard protection mechanisms that all the electronic equipment implements. Consequently, the KNX devices are also protected in such a way that no external interference might disturb their operation. And since all the KNX devices pass from quality control, and they also pass from the certified test labs. Test labs are independent, accredited organizations that perform functional and operational tests on KNX devices. Since they pass also from there, then we ensure that any KNX device in the market fulfills certain criteria concerning safety, security, and operation. This is a guarantee that KNX offers by default, as long as the device has, of course, the KNX logo.
Nice, thank you.
Welcome.
Also, in regards to the energy savings that you were pointing out during the advantages, how energy savings calculations are made based on what? Do you have any more information?
Actually, this is a complete investigation that has been done by several universities around the world. The figures that we used here in this presentation were actually figures given by the research made by the University of Bremen a few years ago. This research can also be found on our website to find out more information about the calculations. The scope of this webinar is not to go through those calculations, but to present the KNX principles. If you want to find out more about those, then please go on our website and you can find those. You can find this research from the university.
Thank you. More questions? How we can replace an old module that it is not anymore available in the market? Do I have to do all the linking again, or is there simply a more simplistic approach?
It depends. the module, the device that is going to be replaced, is going to be replaced by a similar or a same device of the same manufacturer of the same type, then no problem. We simply connect the device again to the installation. So we take out the old one, the defective one, we install the new one, so we wire it, and then we simply reprogram it with ETS. Now, if we're talking about a similar device, so with similar functionality, example given, we have a 4-fold shutter actuator from manufacturer A, and this got defected for whatever reason, then we can get another device from manufacturer B with the same functionality or even extended functionality, install it in the installation, and then do a quick linking again in the software and download it. We do have, of course, in our software features that allow easy device replacement for such cases. Example given, there is an app which is called Device Replacement that does it very, very easily, which can be found on our shop at my.knx.org. I hope I hope I covered you with my answer.
All right. Yeah, no, I think it's good. Also, a quick one. What is the actual ETS version?
5.6.4. I remember that by heart.
Okay, that was quick.
Was that a tricky question or something? I'm joking. I don't know if there are any further questions.
Yeah. Sorry, I think there was a problem with the communication. How many devices I can connect in a bus system? Is there any limit?
That's actually a tricky question. There is always a limit, you know. Some people say sky is the limit, but indeed there is a limit depending, of course, on the calculation or depending on if some system devices like line couplers and interfaces are taken into account. If I'm not mistaken, the maximum number of devices that we could have in an installation is something like 65,500 something. There is a calculation available on our help center about the exact number of devices that can be installed in an installation. And we talk about one installation in one project. Of course, if our project is bigger, then we can, of course, couple installations together. That is perfectly possible. So in theory, we are not limited because we can couple several installations to work together and independently from one another.
Okay. Few more questions before we finish finalize the webinar, because we have a lot of questions, which is actuator. The actuators, you were talking about actuators and sensors. Actuator is always on, off, or maybe a power regulator.
Power.
You can decipher the question.
Actually, I think by power regulator you mean, or the participant who introduced that question meant the dimming actuator, which can actually dim up or down the lights, which is actually kind of power regulation. So yes, it's not only binary switch on and off, but also dimming that exists in KNX, of course. But basically, just to complete my answer, in electricity, all is about switching on and off. So whether we do that gradually or on off, so cut, it's it's the same.
All right. Can we connect KNX with other closed protocols?
Of course, there are gateways offered for that by our manufacturers. We have seen and we know that there are gateways for other closed systems. I wouldn't like to mention them now, but if you simply browse on internet and you look for KNX2, this closed system, I'm pretty sure you can find. But in general, there are interfaces and gateways that do that job.
All right. And the last question, because unfortunately we are running out of time. From which installation size does a KNX system with more expensive devices make sense compared to a conventional installation? From which installation size does a KNX system with more expensive devices make sense compared to a conventional installation? If you can offer your opinion, because I think this is more almost a personal opinion.
Yeah, it's not actually black or white here. Is in fact, as I tried to explain before, that depends on the number, or depends on the functions, on the features that we want to have in an installation. We might have a very, very small apartment, but in that small apartment we might want to have central control, individual temperature control. We might want to have visualization. We might want to control it via internet. We might want to get the weather forecast so that we can adjust the shutters and the temperature inside the apartment. Yeah, actually, with a conventional installation, this is very, very expensive, and to be honest, I really need to think how we can do that. With KNX, it's very easy. So it actually depends on the functionality one wants to have in the installation. So it's not like you have two, and if you want to have three, then it's actually better to have KNX.
Thank you, Vasilis.
You're welcome.
Well, with this question, we can wrap up our webinar here. Thank you, Vasilis, for your expertise and your nice presentation.